In this video, we're going to talk about the Achondrites, the Stony irons, and the iron meteorites. The Achondrites are stony meteorites. The Stony irons are meteorites that have both metallic components and stony components, and the iron meteorites are all metal, mostly iron. All come from a time after the bits of space dust that came together to make our planet had already come together some and began getting reworked from the chondrules and flotsam that initially made them up. Water, radiation, and heat and pressure from collisions were the culprits in this reworking process. Once some of the objects in orbit around the Sun reached 1 kilometer in size, they entered into the next, more furious stage of Earth's evolution as gravity was able to take over from the lesser understood processes that dominated from 1 meter to 1 kilometer. With gravity in charge, these large objects began siphoning the smaller objects around them and absorbing them. And these objects also collided more directly with each other as well, and these two processes rapidly cleared up the matter in the Sun's orbit. So eventually these objects reach planetesimal and then planet size, but that's for in a bit. Our attention's going to stay with the objects once this gravitational smash and grab begins. Before 1 kilometer, the meteorites came together, getting somewhat reworked and beginning to produce Achondrites. But now, the action becomes more fast-paced and the objects grow much bigger as gravity takes over and begins rapidly collecting the available matter. A combination of the energy from the gravitational smashing and the increasing amount of radioactive elements that are emitting radiation internally inside these bodies combine so that the objects get even more reworked. The remaining chondrules disappeared as these bodies heated up and smashed against each other, and a whole new suite of minerals ensued. From the 60 minerals that we saw in stage 1 of mineral evolution in the Chondrites, we're now in the throes of the second stage of mineral evolution, the Achondritic/Planetesimal stage, which ends with 250 minerals. But in order to climb there, we need more than just the Achondrite minerals. The Achondritic objects were caught up in larger and larger bodies. They eventually became massive enough that their gravity forced themselves into an increasingly circular shape. These continued to smash against one another, with far fewer possible collisions available. But as they approached planetesimal size, they began to be able to melt sufficiently to differentiate into different layers. Iron, a relatively heavy element, sank lower and lower as lighter elements made their way higher or remained above. The iron was accompanied by nickel and other iron-loving or siderophilic elements. Above that were the lighter rocky materials or lithophilic, rock-loving elements. There are also the chalcophilic or sulfur-loving elements which form their own group of minerals. It's from these three that the rest of the meteorites come from. The iron meteorites come from the cores. The Achondritic meteorites come from the rocky parts as well as objects that never differentiated but had their chondrules destroyed. And stony iron meteorites come from those regions where the metal core and rocky interior meet and mingle. And that's where we get these combinations of metal and rock within one meteorite. All of these come to us as relatively small objects because these relatively large bodies were smashed up and their mingled bits fall on us from time to time.